All right, so I swear this is the last video. We got caught off again. So again, I have set up my my chart here, and I have decided that I only have one sodium. And I know that I only have one sodium because there's no subscript over here in the formula. So I only need one positive charge because we only have one sodium with a positive 1 charge. I also only have one fluorine because there's only one fluorine in the chemical formula. I'm going to go ahead and add a negative charge here. Because these balance each other out, the total charge of every single one of these, every single one, should have a charge of 0. These cancel out. Cancel. They neutralize each other. Okay, so you're going to fill in the rest of this table with, I don't know if you're going to do groups or a partner or by yourself, depends on what your teacher says. So pause the video, copy down what I have, and I'm erasing. Once you finish, then you can go ahead and continue these notes. I'm going to briefly go ahead and give you what you're supposed to fill in at the bottom here. So there are 5 rules to the chart above. The cation is always listed first. Remember, cations are positive. This cation could be a metal or it could be a polyatomic. The anion is always listed second. Remember, anions are negative. This could be your nonmetal. So in case of the example above, that would be our fluorine, or it could also be a polyatomic. So just so you know, there are positive and negative polyatomic ions. So for instance, a positively charged polyatomic would be NH4+, whereas a negatively charged polyatomic would be like, I don't know, thinking off the top of my head, CO3 2-. Okay. All right, so the third rule here is we need to add subscript numbers if you need more than one atom of that ion. So the example above here, calcium hydroxide, is actually a pretty good example of this. Calcium is our metal, or our cation, and I know this because it has 2 valence electrons. If it has 2 valence electrons, we know that we are going to lose those electrons, and if we lose electrons, we are going to become more positive. We have a polyatomic for our anion because it's the second thing listed, and that is OH-1. We can get this charge from our chart if we weren't given it. Chart. So how are we going to draw our little table here? Well, I'm going to go ahead and create my T-chart. And on this side, I'm going to do my anion, OH-, and on this side, I'm going to do calcium, Ca2+. So every calcium ion has 2 positive charges. But the hydroxide ion, or polyatomic, only has 1-. So I have to add an additional hydroxide. I like to put dotted lines in between to show that it's a different polyatomic or an additional polyatomic. So here, I'm going to add another hydroxide. So over here, I now have 2 hydroxide ions, but only 1 calcium. And you can see that we have presented that over here with this subscript. 2 hydroxide ions, and if there isn't a subscript, we assume that it's 1. All right, you will then also use parentheses and subscript numbers if you need more than one polyatomic ion. And like I said, the example up above is a really great example of that. We need to use those parentheses to distribute that to both of those atoms inside. The overall charge of the chemical formula for all of them is neutral. Always. So this means that the number of electrons lost by the cation must equal the number of electrons gained by the anion.